Okay, so it is exiting, but it's leaving 3 milliseconds. So I'd like to actually get it down to 0. So it only means that, let me look at what I've added here. Okay, so both threads are saying if the value of our digits drops below 0, then we're going to exit from our infinite loop. Both of them are doing that. So the display thread is checking that, and same with the draw thread. But it looks like either order could happen first. So it might have printed that last value before it was actually 0. So maybe if I move that down to the end instead on my infinite loop for the display thread, instead of exiting at the beginning where it would have left the previous printout, and then at the beginning of the next iteration, it would then exit with a lower value for num. Should take care of it, because then it would only exit after it has displayed a value of 0. And I only set it for about a few seconds, so that way we get at the actual output. Oh, the other thing is that it makes me think, because we've got draw thread happening on the same line, notice that there's issues with printing. Is when you make the threads wait a little bit, you can get weird issues with the order of the way things are printed out like this. In the value of seconds, there's only 0 if all 3 digits are 0. And it's not actually overwriting the last amount before it goes to flush out. So we have the flush and then the sleep. So I think we would have to be really careful about the order and how we're going to exit. So let me think through this a little bit. Okay, so it's a very little thing. If we think about the timing of what's going on, before I had it down here, and we had less than 0, but it turns out it will work correctly if I check for equal to 0 and break out of both of them, because I don't want it to display a negative. And then up here, if I had done a little bit of a wait with nano sleep like this, and then check the value of num equal to 0 to break, that means I have printed something that is likely not a 0 value for number before I go to sleep, because meanwhile, the draw thread is decrementing it a little bit faster than we're printing. So these iterations are happening maybe 30 times a second, but yet we're decrementing 1,000 times every second. So we don't want that little bit of nanosleep wait. So a very small issue, but if we want it to function correctly, we have to actually check for the value of num directly after we print. And even then there might be the rare error where it displays the wrong value. If it goes to actually print it, because printing is actually a slow execution compared with a lot of the other stuff we can compute in that time. But if we get it in before the nanosleep, it makes sure that we have only printed a value of 0 before we do in fact wait until our next iteration to print again. So that way the draw thread doesn't have a chance to decrement between our printing. So you can see it go down, and we should just be left with exactly 0 seconds. That's what we want with our timer. We still might even get some issues like we had before with the draw thread printout statement happening on the same line as this one. And you noticed that when it had that output, It did it on the one line. And then when we print draw thread, it's got the end of line character so that it moves down to the next line and continues to print the countdown. So that's another bug I would let everyone else think about. So these little things, you have to be really careful about threaded programming because of the way execution can go between the threads at any time on the CPU. And then when we're iterating with our loop, this draw thread is supposed to happen first, but it was even printing the output statement for the other thread and then switching over to draw thread. And you notice that it happened on the same line. So it can be switching at any moment between the two threads. You got to be really careful. So now I think the very last thing we would do is institute locks. Because we really only want to, and I wanted to demonstrate just making sure that we're only decrementing and we're treating it like a critical region, and printing would happen separately so that we would only decrement and only allow the draw thread to decrement on its own and never allow the other thread for when we're displaying. We want it to only print those digits, or we only want to get access to those digits in here. We would consider these lines to be critical region because we're directly accessing the shared memory of the number between the two threads. So the next thing we want to do is actually make use of the mutex we've got. So when we go to copy the value of seconds and milliseconds, we would want pthread mutex lock. And we would want to give it our mutex. And then let's take a look at the documentation because I always need to remind myself. How many parameters does it take? This is what you would want to do if you're trying to learn how to program with your threads and you want to remind yourself what you've got to work with. We want to use pthread mutex lock to enter or check to enter the critical region and use our mutex variable. It only takes the one memory address. So that's why I'm just passing in, and we've got it as a global variable, and I'm passing in the memory address of that variable. Since it's global, this would be a shared mutex with the other thread as well. And we only need it up to here. So I'm just going to keep it straightforward. And I'm not going to worry about entering a critical region just for this one line and then just for this one next line. But we could do if we wanted to. Do a lock here and then directly unlock right away after. And then again, lock when we want to access it, the value of num again. If we needed to do that, we could do that. For now, I think it's okay to get away with just having one other line. But later on, if you're using mutexes and keeping track of your critical regions, you'd want to be more picky. And then down in our draw, where we decrement, we also want to use our mutex. All right. This should make it so that only one thread at a time is going to access this shared resource, what we've passed into both threads. And we could name it the same if we wanted in both threads as well. That could make it a bit easier to keep track of what's going on in your own code. But again, it doesn't have to be. So that's what might make it tricky if you're working on a team with other programmers. You might have multiple threads and you're all writing different code, and the code for each thread might be going in a completely separate source code file. And then it might be difficult to keep track of what's going on between the shared resources. So they might not be named the same in that case. And you'd have to communicate with the other members on your team to make sure you've got your code styled the way you want it to. This should be enough if we're not accessing it anywhere else other than here to check for breaking. But that's where you would want to be careful. If both of them are just reading from the value of num, that should be fine. Let me think through this. If this has entered its critical region, it would decrement, and the other thread would not be changing the value of our digit, so that's fine. So that at some point we will exit this infinite loop and we won't get stuck. And then up here, I want to make sure to think through if I've locked, it's not going to have to wait forever for the other one to exit its lock because it's only got the one line. There's nothing else that's going to stop that from exiting its critical region. So I'm pretty sure we don't have any deadlocks to worry about. And this is one of the major issues you definitely have to be concerned with when you've got critical regions and multiple threads. And when you go to lock and unlock, are you going to get stuck in one of them or maybe both of them and hang in your program? Okay, so it would then grab the values. I don't think anything else would make it sit there waiting at all. It would exit its critical region and then continue on. And eventually, it would be able to check the value of the number to see if it's zero to break out of its infinite loop. So we should be okay. As far as the execution of the actual program, the way we observe it running, it should look exactly the same. And there we go. So this is the basic idea behind your locks and creating your critical region. Maybe in terms of style, you might want to indent between your mutex lock and unlock. And you might like to do that just to make sure you're thinking of it as a critical region. I'll be posting this code together with the video, so that way you can take a look at everything, get more comfortable with working with threads, and now thinking about working with locks and critical regions. So we only have the one shared resource here. What was it we passed in? The allocation for our digits, and really I should be deallocating that here at the end. If I have an malloc statement, then I should have a free statement to match somewhere in my program. And that way I release the memory that I asked for from the heap and it goes back into the heap. The program could continue on. We could write more code after the free. And if we make a call to free, we could continue to use the variable just if we wanted to, but if you were going to continue to use it like that, you would want to allocate it again after you set the pointer to null, just to make sure you're not accessing that old memory address where you released the heap memory, because that is a security issue. So anytime you're freeing your pointers, it's a good idea to also set those pointers to null directly afterwards. And you could continue to then reallocate them to something else if you wanted to make use of those pointers again later. I think that's the very last thing to be concerned with here. So many things to think about in C programming, but it's really good to become familiar with accessing memory, allocating and deallocating, and then starting to get more comfortable with parallel programming. I think you've got a lot of power once you know how to work with that. I always find the time spec and making calls to nanosleep help me a lot when I want to start debugging my threads, because I can control what's happening a little bit more and when things are happening. Because if you go to try to do output statements to print things, if you have no control over the timing of stuff, it just ends up being really difficult to debug because you can't even read your output to get any idea what's going on there. So printing to debug, not the greatest, but in a pinch, it will work. And I wouldn't mind getting a little bit more comfortable looking at how to work with debugging in GDB with threads and switching between them within GDB. So maybe something for in a couple more weeks.